Hello friends, today we will study what is merge sort. Merge sort is a sorting technique which uses the strategy of divide and conquer. Now what happens when I use the merge sort algorithm? In merge sort, if we have to sort any element, we've taken a simple example over here, and this is how my merge sort will actually be implemented. I have 7 elements in my array, that is, I have a list of 7 elements. How does the merge sort work? We know that it works on a strategy of divide and conquer. So first thing is, we have to divide this particular list of elements till it reaches single element each. So the division happens in the recursive manner, that is, recursion comes into picture over here. If you see in this example, we have split the list of array into 2 parts, that is of the size 4 and 3. So the elements are split. Now the next step that comes, it is further split till it reaches single element. When I reach the 4th level of my diagram, I see all the elements are split into single element each in the list. Now comes the solution to my divide and conquer technique. Now I start conquering each and every sub problem to solve the problem. So what I do, using the merge sort algorithm, I merge two elements each. So first 2 elements of 38 and 27 are taken, that is, they are merged together. As we are studying merge sort, so these 2 elements are sorted in between themselves. As 27 is less than 38, so 27 comes first and 38 goes next. Then we sort 43 and 3. That is, we conquer the 2 sub-solutions of 43 and 3 and merge them to get 3 and 43 as my sorted sublist. The next element is 9 and 82. Now what do? I see 9 and 82 are already sorted, so I merge them together and I keep the list as it is. As we have 7 elements in the list, the last one, element 10, remains as it is. Again the recursive procedure is followed in the concurrence. So what happens is, the two elements which were sorted among themselves are now joined. So 27, 38, 3 and 43 are merged together and sorted among themselves. So I get a list 3, 27, 38 and 43. And then the last 3 elements are joined together and sorted. So we see that the merge sort uses a simple strategy of divide and conquer with implementing the recursion. So when we reach the last step, the array element, the list of elements are sorted. Here it is advantageous to use divide and conquer technique, as I don't have to start sorting the elements and comparing them from the first part of the list to the last part of the list, that is the unsorted zone and the sorted zone that we usually follow in the deterministic algorithms or the simple sorting techniques. So here what we have done, we have divided the elements and then recursively made the list into single element, and then we have merged them, sorted them, and in the end we see that all the sub problems, the solutions of the sub problems, gave us a final sorted solution to my list. Now, how does the merge sort works? In the simple technical word, merge sort splits the array. If the array is of size n, that is, n is the size 7, so here the array is taken from 0 to n minus 1 into equal halves and make copies of each half of the array in B and C. Here we had split the array A, which was of the size 7, into two parts, that is 4 and 3. So the 4 part goes to the array B and 3 goes to the array C. Sort arrays B and C recursively, that is, we keep splitting the arrays B and C. Merge the sorted arrays B and C into the array A as following. These are the following steps that we need to follow when we have to merge the particular sorted list. Repeat the following until no elements remain in one of the arrays. That is, when we have split array A into two parts, that is B and C, and each sub problem gave me a definite solution. Then when I am merging the two, then not a single element should be left out in the arrays B and C. Compare the first element in the remaining unprocessed portions of the array. Now copy the smaller of the two into A. So what we do, as we merge, whatever is the smallest element after combining the two arrays is copied into A, while incrementing the index indicating the unprocessed portion of that particular array. Once all the elements in one of the arrays are processed, copy the remaining unprocessed elements from the other array into A. So this is how I keep moving, or I keep splitting my array recursively till all my elements are sorted. Now algorithm for the merge sort of the size A, array A of the size 0 to n-1 follows these particular steps. Sorts array A 0 to n-1 by recursive merge sort is my problem statement. What is the input to my array? Input to my array is elements in the array A, which is of the size n, which has been defined, and the input list is taken from the user. And output array A of the size 0 to n-1, it is sorted in ascending order. Here we are taking an example of sorting the list in ascending order. If n is greater than 1, that is, I will be using this algorithm if the size of my array is greater than 1, that is, I have some elements in the list to sort. If the size of my list is 0, then there is no point implementing any sorting terminology or technology. Now what happens? Copy A, array A 0 to n/2 to B to 0 to n/2 minus 1. Means if I had, for example, the array of the size 7, I have split it into two parts. If I have split it into two parts, so my array B was of the size 4. As I am starting my array from the index variable 0, so it has to go from 0 to 3, not 0 to 4. That is the reason we say copy A 0 to n/2, that is when I have split it into two parts, to 0 to n/2 minus 1 into the array B. Now copy till I have copied the array into B. Now after the next location, I have to copy it into the array C. So copy A n/2 to n-1 to the array C. So the remaining elements which were not copied to B, the split part now is copied to array C. Now after I have split the two, apply merge sort to my array B and I apply merge sort to the array C. That is, it will be recursively split, and till one single element in the list is found, it will then be using the application of the merge sort technique. And then B and C arrays which are sorted using merge sort are combined in the array A, which is the main array which had the first one, the unsorted list. As we have seen the algorithm of merge sort, Now we see how actually the merge sort is implemented. What happens is we write a function which is known as merge sort. Here, if you see the three data types, the variables are int a, that is an array A which takes the input, int I and int j, the two sizes that are taken, and I declare a variable called mid. Now mid will find the middle value from the list, as I is the initial value of the array size and j is the length, that is the end of my array size. So here my A of I has the list of elements which are passed from my main function to this particular function. I check if I is less than j, that is if my initial position, if the initial index is less than my final index of the array, then only I can continue in this particular function, that is then only I can implement. If my initial value is more than my final, then I cannot sort any array element or any list in either ascending or descending order. Now what happens? I have to first find is the mid, as we have seen in the algorithm. So here we have got the values of I and j from the main function. So we find the mid. The mid is found in a very simpler manner, that is I add the initial value plus the final value divided by 2. As I get the mid of my list, then what do? I call this merge sort recursively, where I pass the value of array again A, I is the initial value and the mid value. Here if you will observe, for the left recursion, that is for my array which is split and saved in array B, that is on the left hand side, my middle value becomes the last value of my array size. So here it is used for left recursion, that is for the array B recursion. And then I have merge sort A, the list of my elements, and here you will see the mid plus 1 is my initial value. Whatever is stored in array B, now I have to store the remaining element in array C. So that is known as the right recursion, and j is the last element of the array, that is the size of my list. After I have stored the left recursion and the right recursion in my array A and B, so the merge sort left recursion will be called continuously till my I becomes greater than j. Then I come to the right recursion, that is all my number of elements in the array or the list are split into single elements. Then I call the third important function, which is known as merge. Here we are working on the merge sort function. Next we will see that after having recursively used left recursion and right recursion on the arrays A and B, how do we merge them? So we merge them with the values you see we pass are the 5 values to this function, and those 5 values are A, my actual array, that is my actual list, I is my initial value of the array A, then the mid that I have found in this particular function, mid plus 1 for the next array, that is the array C, and j, which is the size of my array or the last element of my array. And this particular function is used for merging the two sorted sub arrays, and here my sub arrays are B and C. And this is a small merge sort recursive function that is used and that can be implemented and that can be written if anywhere asked to write the recursive merge sort function. Now we see how does the function merge works. We have seen that the merge sort will split each and every element of the list into a single element. Now how do I merge them together? Now this merge function is used to merge all the split element and then sort them accordingly and use the conquer strategy to finally give me a output. So void merge, as we have seen in the merge sort function, that I pass 5 values to this particular merge function. So here the 5 values are int a, which is the array A, the initial list which I had. The value of I comes and here gets stored in the value I1. The value of mid goes to J1, mid plus 1 goes to I2, and int J2 gets the value of J. So here you see how the values are passed from the calling function to the function definition. Here I have declared a simple variable temp, which is of the type array size 50, and it is an integer. Now this array is a temporary array which will be used for storing the merged elements. Now what do? I again declare 3 variables I, j and k. You can see I and j are declared again in this merge variable, but these variables are declared inside this particular function. So they are local to this function. It does not has any reference to the values of I and j which are used in the merge sort function. So I and j are local variables to this function which is known as void merge, and life of this local variables will be only till this function is executing. I say I is equal to value of I1. So whatever is my previous value of I which was passed to I1, that is the beginning of the first list, is assigned to I. J is equal to I2, that is the beginning of the second list is assigned to the variable J. K is a simple variable which is taken for iteration purpose as k is equal to 0. Now while I is less than and equal to J1 and J is less than or equal to J2, while elements in both the list are existing, we are supposed to keep on checking and comparing using a simple sort, that if A of I is less than A of J, then I keep on moving the element from my array A to my temporary array. Else if they are not equal, if A of I is not less than A of J, then what do? Then whatever is the array size in my second list, that is array J. J is the beginning of the second list, so that is moved to my temporary location or the temporary array. Here you will see what is happening. If first array value is less than the second array value, then it is moved to the temporary location or the temporary array. If it is not, then the second array elements are moved to the temporary location. And then what happens? If the value of I, that is while the value of I is less than J1, then copying remaining elements of the list to the first list. Then what happens is we just move all the remaining elements of the array A of I to temp. And while J is less than equal to J2, then we are copying the remaining elements of the second array into the temporary array. So now what happens? You will see there are no curly braces in the while loop because there are only single statements in all my while loops. If the remaining elements in array list 1, that is array B, then all the remaining elements are copied. If it is on the second array, that is C, then all my remaining lists are copied. Now what we have to do? We have transferred and the sorted list from B and C to the temporary array. Now we have to move this small sub problem solution which was stored in the temporary array to the main array A. So we use a simple for loop to transfer the complete array or to copy the complete array temp to A. Then we will see the pictorial sort representation of merge sort. The non-recursive version of merge sort starts from merging single elements into sort parts. You will see this all single elements are merged together and then they are split. The analysis of merge sort shows that all cases has the efficiency of theta n log n, that is the complexity of the merge sort is theta n log n, and it follows the equation Tn 2Tn by 2 plus theta n is the function where the size of n is 1, that is T of 1 is equal to 0. We have seen that number of occurrences in the worst case is close to the theoretical minimum for comparison based sorting. Now what do you mean by the term comparison based sorting? The comparison based sorting techniques were techniques where each and every element was compared with every element in the list. That is the first element with second, third, fourth in the linear sorting or the sequential sorting example. Whereas in this case of merge sort, that will be the scenario for the worst case complexity. Now what happens now? If you see in the efficiency, we have said it is theta n log n. So the function follows the complexity of the type theta n, and we try to divide the subproblems into n by 2 proportions, that is we keep on splitting, that is we keep on dividing the problem into small subproblems. So the equation of Tn is equal to 2Tn by 2 plus theta n holds the best when T of n is 0. Now if I have a problem or if I have a comparison based sorting which is log to the base 2 n factorial, then it compiles to or it compares to, it leads to n log to the base 2n minus 1.44 n. This is a simple theoretical based equation which has been derived to find the complexity. Now the space requirement for the merge sort is theta n, and it can be implemented without recursion also. It is not necessary that I always implement merge sort with recursion. Without recursion, what we can do is we can just split the array into 2 and not keep on splitting till it reaches single element of the array. Some follow the terminology and technology or the value of proceeding as I split the array into 2 and then apply the simple bubble sorting techniques to the 2 split arrays and then merge the 2 split arrays into 1. So my 2 subproblems, if not needed to be solved recursively, then what happens is we just split the arrays into 2 and apply the simple bubble sort algorithm on it and then merge the 2 sorted arrays. Thank you.